Hello, everyone. So my name is Victoria Reichelderfer, and this is my partner, Isaiah Carrington. And our project was an analysis of polymer adhesion with various coatings used in equipment made by our industry sponsor, Farrell Palmini. Our faculty advisor for this project is Monty Shaw from the Institute of Material Science.
So like Victoria said, this project deals with polymer processing equipment made by Farrell, and there are certain problems that occur on the inside of this polymer processing equipment where you have a chamber with a screw spinning and pushing polymers against the wall to generate heat and causing them to melt. And Farrell uses different coatings on the surface of their equipment to reduce the wear on the machine from additives and pigments that can be abrasive. But these surface coatings sometimes cause the polymers to stick to the equipment. And when polymer gets stuck in the wrong places, it causes machines to decrease in productivity. Now, we want to know which polymers will stick the most and least on different metal surfaces, and we hope to improve the quality of Farrell's machines. With our original plan was to obtain data about this.
So we've come up with a way to quantify the adhesion between polymers and coatings used by Farrell that can serve as a procedure for testing new coatings that they may develop in the future, and also give insight into the information that we need for our project. So the experiment that we came up with is pretty simple in nature, but it can actually give us a lot of information. It's very similar to the standard TAC test, which is used for pressure-sensitive adhesives, and that is an ASTM standard. So we just modified that a little bit. So essentially what we do is we take a little bit of the polymer material and we melt it onto a small steel plate, which we machined at UConn. And that plate is coated with one of 7 coatings that Farrell uses in their equipment. And then once that polymer is melted, we mechanically pull the melt off the plate and record the force required to do so. So our original plan was to repeat this procedure for several common polymers used by Farrell's clients. So some with additives and some without. And we wanted to do that so that the data we collected would accurately reflect industrial conditions and give a broad range of data for the companies. The coatings varied in both chemical composition and surface roughness. And so the reason we did that was because we wanted to know not only how much adhesion was occurring, which we would find out from that normal force test, but also why that adhesion is occurring. So does it have more to do with the chemical composition of these coatings, or is it more to do with the actual physical characteristics like roughness of the coatings? So that was the original plan. We did get partially through that original plan, but unfortunately we couldn't go as in depth as we wanted to for this project. But thank you for listening. I hope you enjoyed this description of the work. Thanks.